Welcome. I'm absolutely thrilled you're here today because we are going on a seriously fascinating journey. We're going to build a mental scaffold of the entire modern IT landscape. We'll start by looking at the absolute smallest microscopic components inside your smartphone, and then we're going to zoom all the way out to the massive global cloud infrastructure that literally runs our modern world. If you've ever felt overwhelmed by all the tech jargon out there or just kind of wondered how all these random pieces actually fit together, you are in exactly the right place. Here's our roadmap for today. First, we'll cover hardware and software basics. Second, we'll scale up from servers to virtual machines. Third, we're demystifying the cloud. And finally, connecting it all together with networking. Let's jump right in. Okay, part one, hardware and software basics. Before we can understand those massive global networks, we really need to anchor ourselves with the foundational building blocks of computing. What's super fascinating about these 5 core hardware components is that they exist in practically every computing device you touch. Whether it's your smart fridge, an iPad, or a $1 million server sitting in some massive data center, the architecture is fundamentally the exact same. You've got the CPU, right? That's the brain actually processing the instructions. You have the RAM, which is basically your temporary workspace. When you open up a web browser, it runs in the RAM. But if your battery dies, that RAM clears right out. And that is exactly why we need the HDD or SSD. That's your persistent, permanent storage. It's where your photos and files live safely even when the power is totally off. Then we have the NIC, the network interface card, giving your device a connection to the outside world. And finally, the GPU, which acts as an accelerator for graphics and video. Now, hardware is really just metal and silicon until we actually give it instructions, right? And there are 2 distinct software layers we need to look at here. First is the system software, your operating system. So think Windows, Linux, or iOS. The OS is the boss. It manages the hardware resources, handles all the security, and coordinates the whole shebang. But let's be real. You don't buy a phone just to stare at the operating system. You buy it for the applications. Applications sit right on top of the OS and are built for very specific tasks. When you tap the Uber app to book a ride, that application sends instructions to your iOS, which then talks to your phone's network card to fire that request out into the world. Moving to Section 2, servers to virtual machines. We've got the basics down, so let's see what happens when we need to serve not just one person, but thousands of users. To handle thousands of users, companies traditionally scaled up by buying massive physical servers. These are essentially incredibly powerful versions of your laptop, just designed to slide into metal racks. But I have to ask, is a giant physical bare metal server the magic solution? Historically, the answer was actually a resounding no. Traditional IT faced some massive bottlenecks. Physical servers were ridiculously expensive and, honestly, notoriously underutilized. Imagine dropping a ton of money on a powerful server, but your application only ever uses 20% of its brainpower. The rest of it is just sitting there, totally wasted. Plus, if your app suddenly went viral, ordering and installing a brand new physical server could literally take weeks, sometimes months. So how did the industry solve this massive bottleneck? Enter the virtualization stack. This was a total game changer. Instead of one physical server running just one application, engineers created this brilliant piece of software called a hypervisor. You install the hypervisor directly onto the physical hardware, and it allows you to slice that one physical machine into multiple completely isolated virtual machines, or VMs. Each VM acts entirely like its own independent physical server. You could literally be running Windows on one VM and Linux on another, and they are both sharing the exact same physical CPU and RAM underneath. This drastically improved utilization and meant IT teams could spin up a new server in seconds instead of months. All right, Section 3, demystifying the cloud. We virtualized our server room, but what happens when we take that exact concept and scale it across data centers the size of football fields? To truly wrap your head around the cloud, you have to understand the massive financial revolution it caused. Back in the day with on-premises data centers, companies were stuck using a CapEx, or capital expenditure model. They had to pay millions upfront just to buy the real estate, the cooling systems, the physical servers. If a startup just wanted to test a new idea, that financial barrier was huge. Cloud computing flipped this completely on its head into an OpEx, or operational expenditure model. Think of the cloud exactly like your water or electricity bill. You don't build a multi-million-dollar power plant just to turn on a light in your house, right? You just pay the utility company for the exact amount of electricity you use. In the cloud, the vendor manages all that physical space. You just click a button, rent a virtual machine instantly, and if you turn it off an hour later, you literally only pay for that 1 hour. Now, I really want to bust a major industry myth right here. You are going to hear people say that the cloud is just someone else's computer, or that it's just a big data center. That is absolutely false. The cloud is not just a data center. Obviously, yes, it relies on massive physical buildings packed with servers, like Amazon's huge facilities over in Mumbai. But what actually makes it the cloud is the vast, incredibly complex layer of automated, orchestrated services running on top of that hardware. It's the web portal that lets you instantly deploy a database, set up a global network, and configure AI tools without ever having to talk to a human being or plug in a single cable. Because the cloud is driven by all that software orchestration, it offers us different levels of service. Let's unpack these acronyms really quick. IaaS, or Infrastructure as a Service, is when you're just renting the raw virtual hardware from the provider, but you're still on the hook to install and manage the operating system yourself. If we step up a level to PaaS, Platform as a Service, the vendor manages the hardware and the operating system for you. You basically just bring your own custom code. And finally, SaaS, Software as a Service. You use this literally every single day. Every time you open up Netflix, jump on a Zoom call, or check your Gmail, you are using SaaS. You aren't managing any hardware or writing any code, you're just consuming a fully pre-built application right over the internet. So who's actually running the cloud? Looking at the data, three heavyweights completely dominate the public cloud market. Amazon Web Services, AWS, leads the pack with about 30% of the market. And because Amazon fundamentally understands e-commerce, AWS is just incredibly strong for e-commerce infrastructure. Then you have Microsoft Azure coming in at 20%, and Google Cloud Platform, GCP, holding about 13%. But here's what's really interesting. One size definitely does not fit all. While AWS is the undisputed infrastructure giant, the data shows that Azure and GCP heavily excel when it comes to artificial intelligence and machine learning. Because of that, a lot of modern companies actually use a multi-cloud approach, basically cherry-picking the absolute best tools from each provider. And finally, Section 4, connecting it all through networking. We've covered the hardware, the software, those massive cloud data centers, but none of this matters if these machines can't actually talk to each other. When data moves across a network, it flows in one of three primary ways, and understanding this is absolutely key. First up is unicast. This is simple one-to-one communication. So when you log in to check your personal bank balance, that's a direct, private unicast conversation happening between your phone and the bank server. Second is multicast, which is one-to-a-group. Think of a hotel streaming an on-demand movie to several very specific rooms at the same time. And finally, we have broadcast. This is one-to-all. It's exactly like a PA system at an airport announcing a boarding call. Every single device on that network segment hears the message, whether it was actually meant for them or not. Now, in a local area network or a LAN, like the one you'd find in a typical office, we need physical devices to plug all our computers into. Let's look at how this evolved. In the early days, we used something called a hub. A hub is essentially a pretty dumb device. If one computer sends a print job to the printer, the hub just broadcasts that data to every single computer plugged into it. It wastes a massive amount of bandwidth, and as you can guess, it's terrible for security. Thankfully, we evolved to the switch. A switch is intelligent hardware. It actually learns exactly which device is plugged into which specific port. So now when that computer sends a print job, the switch routes it directly and only to the printer. It segments the traffic, making the whole network incredibly fast and secure. But switches only connect devices locally. What happens if your office in New York needs to talk to that cloud data center over in Mumbai? Well, that is where the router comes in. Routers are the crucial bridge. They act as these intelligent gateways that connect entirely different networks together. Your home Wi-Fi router connects your private local network, your LAN, out to the massive public wide area network, the WAN, which we all just call the internet. Routers are basically the traffic directors of the global digital highway, making sure your unicast banking request actually makes it all the way across the continent. And just like that, we've built the scaffold. We've journeyed from the microscopic silicon of a CPU up through the ingenuity of virtual machines, scaled all the way up to the boundless utility of the public cloud, and finally connected the whole thing across the globe with intelligent networking. The modern IT landscape really isn't a mystery anymore. It's just this incredible playground of interconnected tools. So with this new map in your hands, I want to leave you with one big question. Where are you going to build your future? Will you dive deeper into the architecture of the cloud, master the complex pathways of networking, or maybe bridge the gap with DevOps? The foundation is yours now. Keep learning, and I'll catch you next time.